All right. We are recording. Does it pop up with a prompt saying, do you guys consent to be recorded? No. Okay. That happened in a meeting I had today, so I got to figure out what that is and if that's something I should be doing. Welcome back, everyone. Hopefully your lab this week, your first fully virtual lab, wasn't too painful. If you have lab on Monday, Wednesday nights, I know that Mindra is going to be present this evening again and be there to help you finish and work on anything you need. So hopefully you'll be able to get any questions answered. But he did send an email out this afternoon at the request of, I think it was Michael, and I think someone else sent him an email requesting that he specifies a little bit more of what he's asking. Taylor, I'm going to remind you to mute, or I guess everyone, just go ahead and mute your mics if you're not talking. I just muted Taylor, so I hope you don't mind. Do you all have any questions on the credit, no credit option that the university is now making available to our course?
Yeah, what exactly is that?
So basically, we're going to keep grades just like it's normal semester. So you still have grades coming from iClicker, from OWL, from the exams we'll do on OWL, which we have to rely on the honor system as much as we can because it is what it is. And we're going to take your grades from lab as well. And at the end of the semester, you'll see a percentage. That percentage will either translate into a letter grade based on the percentage you have, or you might decide that you want to do a credit option or no credit. And unless things change, meet you again, Taylor. Unless things change, I think it's going to be a 70% cutoff or above is credit. Anything below that is no credit. Either one of those two options does not impact your GPA. So there is a decision tree that was sent out from the provost office to all students that allows, kind of guides you through when you might want to choose credit or no credit. If you have below a 70%, you'll probably want to choose no credit because then it won't impact your GPA. If you're above it, then there's a whole bunch of information that you probably need to make a decision for which one is going to be best for you and your GPA and that kind of thing going forward, whether it'll increase or decrease your GPA. But that is a decision that I have to have in writing from you that you want credit or no credit versus your letter grade. If I don't have that in writing, then I'm not allowed to give that option to implement that. So it is by no means being implemented to you. It is a choice that you will have available to you. Does that clarify it, Sarah?
Yeah, it does.
Great.
Do you have a whiteboard in your house?
I mean, who doesn't?
That's pretty awesome, man.
That's why I had a beach on before, because I figured I'd get made fun of for it.
Nice.
My wife's a professor too, so she's in the med school, and we both write out our ideas on our whiteboard in our house. It's an 8-foot whiteboard. Everyone has an 8-foot whiteboard in their house. Come on, right?
Makes sense.
Yeah, I'm glad you think so. Thanks, Carter. All right, so we're gonna go ahead and jump into our class tonight if I don't get attacked by a fly. Hopefully the primer today wasn't too challenging or too crazy off kilter because we talked about some of the concepts in class last time, and we're gonna build off of that and kind of, I really want us to get more and more comfortable and familiar with what acid-base chemistry is and hopefully some of the calculations around it, but the calculation should come second. I want you to understand the concepts first. So if you get stuck at any point, please ask questions. So the first thing I'm going to do is share my screen. And then with the screen shared, go ahead and go full screen mode. And this question's already sent out, I believe, on iClickers. Do you see my presenter mode or do you see the full screen? Full screen?
Full screen.
Great, thank you. So go ahead and send out your clicker responses. We're probably, do you want to discuss this with each other? Thumbs up, thumbs down? Do you want a breakout room for 1 minute? Thumbs up. Okay, we'll do breakout rooms for 1 minute. I'm going to send you to breakout rooms automatically. Let's see, we have 24 participants. Let's do 4 rooms, go. Open all rooms.
Is this back in the main room?
We are back in the main room.
Okay.
Hey, Dr. Bailey, where's your cool background at?
I decided to actually show you guys my house today.
Oh, okay, cool.
Get made fun of by Carter. All right, looks like we got just about everybody back. Couple more. All right, we had a pretty unanimous decision on this one. Can I hear from Verda? Which answer did you choose and why?
I said B because the conjugate for H2PO4 would be HPO4 because it can only have a difference of 1 hydrogen.
Okay, so if you had the conjugate base pair of B, then that would look like D. Is that what you're saying? D as in dog?
Yeah.
Okay, so then what about answer A? Then that one's wrong?
No, because it's H3PO4 and then H2PO4.
Okay, so I'm just gonna push a little bit on one of the things you said at first. You said in order to be a conjugate pair with H2PO4 minus, it has to have 1 less proton. And so it has to either have 1 more or 1 less. And so this example is nice because usually when we think about an acid, it's something that gives off 1 proton. But in this case, when we're looking at H3PO4, that's phosphoric acid. And phosphoric acid actually has 3 protons that it can give up. And so there are multiple different conjugate acid base pairs, which only differ by 1 proton. So I'm going to go ahead and share my screen again. I'll move you guys over here. All right. So for any chemical reaction, what we're going to be talking about is that we can have something act as an acid. And when it does, I've highlighted it in green here. It acts as an acid with water acting as a base. And we're going to see this over and over again, that to define the strictest definition of if something acts as an acid or base, we say, how does it interact with water? Does it donate a proton to water, or does it accept a proton from water? And so in this case, HCO3 minus bicarbonate, that donates a proton to water and ends up generating carbonate. That means that water in this case acted as a base and it accepted a proton. If we think about the reverse reaction, what are the things on the right if we talk about is this an acid or is this a base? Then the way that we talk about those is not just drawing it backwards. We want to make sure that we're drawing it as what is this going to do if it interacts with water? So we say, how does that conjugate base of our weak acid interact with water? So it's really important that we pay attention, close attention to the difference between it's not interacting with H3O plus, it's interacting with water itself. And in this case, water is the one that's donating a proton, and that CO3 2 minus or carbonate is acting as a base in this case. So if we were to have Ka and Kb to describe these two reactions, which one would be Ka and which one would be Kb? Can I have a volunteer? Let's say Tracy.
You're talking about the top one, the acid reaction.
So is this reaction considered a description of Ka or Kb?
Ka
And then the bottom one?
is Kb.
Great. So remember, Ka and Kb are always something reacting with water. And if that thing donates a proton, that's describing Ka. If that thing accepts a proton from water, it's Kb. So why are we doing this? Why do we care? This is an example. So I'll read through it. And basically we're talking about when we have a mixture of a conjugate acid-base pair. So EPA is concerned about a small lake in a mine just south of Little Rock where sulfuric acid was used. The water contains many species, but we're going to focus on the conjugate acid-base pair, which is hydrogen sulfate and sulfate, due to how acidic the lake currently is. So you guys know the lakes I'm talking about. There's some mines just south of Little Rock, just south of the airport. And so we can go and we can measure the concentration of those two components in the lake. And in the next week, we should be able to calculate the pH of that lake. And then the question is going to become, how do we make the lake less acidic? What are some different ways that we can do that? And so these are the types of questions that I want you to be able to answer after we've gone through some of this acid-base chemistry. And we're going to be talking about buffers. This will probably actually be the next 2+ weeks. So one of the proposed ideas is to make the lake less acidic. The mining companies proposed dumping metric tons of calcium hydroxide into the lake. Can we figure out what the final pH of this lake is going to be? So I'd say in probably 3 weeks, this is the type of question that we should all be able to answer. So my objectives for today are not as grand as those. I want you to be able to identify an acid-base conjugate pair, which it sounds like most people are pretty comfortable doing. I want you to be able to calculate a pH of a solution, either given the Ka or Kb, an initial concentration of a weak acid or a weak base, or a strong acid or strong base. I want you to be able to compare the relative strength of an acid or base using Ka or Kb. And then if we have Ka or Kb, to find the other one. To be able to convert from any one of these measurements of concentration or acidity or basicity to any of the others. And then determine whether a salt solution is acidic or basic. And this is where we start to get people to trip up, where things seem pretty straightforward, and then they're not so much anymore. I should probably note right now as well that if you have not already downloaded the Word document that has the worksheet on it that was sent out an announcement today, I'll try to do that by noon every day that we have class. Highly advise printing it out and writing on it. It just gives you more time to process. If you're writing down the question and writing out your answer, we lose about 1 minute per question. And as you know, I ask a lot of questions in class. So that will really slow you down. So that's why I'd really like for you to print it out or have it on a tablet that you can write it out with. So if you haven't already done that, please pull up that email and download that file. And if nothing else for today, just have that up on your screen and kind of flip back and forth between the worksheet. Maybe you can just write number 1 and then write out your answer, knowing that it correlates back to that worksheet. Something like that to kind of keep up. So one of the things we didn't really talk about in too much detail last class, but I think is a really important component of what we're going to be doing with acids and bases, is this discussion of where Ka and Kb relate to each other and why they relate to each other. So I briefly mentioned autoionization of water, where if you have a ton of water, every once in a while, you're going to have 2 water molecules bump into each other and they're going to trade a proton. One is going to act as an acid, one is going to act as a base, and you end up getting H3O plus and OH minus. So this is described, that equilibrium constant is described by Kw. And remember, in our current Ks that we're looking at, we're not going to include the concentration of water because there's so much of it. So we're just going to describe anything else besides water. So Kw is a concentration of products raised to their stoichiometric coefficient divided by 1. So this is our Kw value. Hopefully from the last couple of slides, we're on the same page that to describe the strength of any acid, right? Something, this is a generic something attached to an acidic proton, that if that goes into water, it's going to donate a proton to water and generate H3O plus, and then leave behind some other component that has one less H plus than it did to start with. And that's what we call Ka. So Ka is without water, again, concentration of products raised to the stoichiometric coefficients divided by concentration of the reactant that's not water. We can say the same thing about how does this thing act as a base. Once again, A minus, that rest of the molecule interacting with water, pulling a proton from it, acting as a base. When it does get its proton back, now we're left with OH minus, and that's Kb. Concentration of products raised to stoichiometric coefficients divided by concentration of reactants. And so the relationship that comes out of this, because both of these are focused on how a conjugate acid base pair, remember it's always just one conjugate acid base pair differing by one proton. How does that interact with water? If both of these weren't water, then we couldn't do this. If both of these weren't the same conjugate acid base pair, we couldn't do this. So the next thing I'm going to do is I'm going to multiply Ka times Kb. So if we do that, we have Ka times Kb. So can I have someone tell me mathematically, do we get anything canceling out in this multiplication? That's for
The HA and the A minus would cancel out.
So we have HA on the top and the bottom, A minus on the top and the bottom. So Taylor, what's left after we cancel those things out?
The H3O and the OH
Concentration of
concentrations.
H3O plus, concentration of OH minus. Does that look familiar?
KW.
Okay, so that's where this relationship comes from. As long as we're focused on how does the conjugate acid base pair interact with water, then this plays out. So if we have Ka of one acid in solution, and we happen to have a totally different base in solution, we can't compare those through this relationship. It has to be focused on the Ka, Kb of the same conjugate acid base pair. And I just wrote out the same thing. How do we get it? There we go. At 25 degrees Celsius, Kw also equals this particular value. And that number becomes really important. And I kind of glanced over a bit quickly last class, but if we have a neutral solution of water, 1 times 10 to the negative 7th molar concentration of H3O plus, 1 times 10 to the negative 7 concentration of OH minus. Neutral water means we have the same concentration of OH minus and H3O plus. Basically, we're saying that if water is neutral, this is going to happen. We're going to form one of these and one of these, the same number of both of those. And if we do that, and we don't have any outside influence, we don't have anyone adding H3O plus to the solution, then all of the solution is going to have an equal mixture of H3O plus and OH minus. That's when pH equals 7, which means that POH also equals 7. So this is kind of where a lot of the calculations we're going to be doing are based off of. So I thought it was worth taking a little bit of time to go through this. Are there any questions on the relationship between Kw, Ka, Kb, pH, POH? And I guess the way to say this is pH plus POH equals pKw, which is 14. Any questions? Please, questions? I can't see everybody, so you're going to have to unmute and speak up if you have questions while we're in slide sharing mode. Okay. I think we're good to move on. So the next step is I want you to figure out what the pH of this solution is. And in order to do that, I'm going to send you into breakout rooms. And I think they're all pretty even, 6, 6, 7, 6. Did anyone not have a facilitator in their room? Looks like there's one in every room, and I'll go into room 4 again.
I think we came out really quickly. Did you guys really have no questions? Because
Oh no, I didn't have any.
No, me neither. That's what I was wondering where everybody else is at.
How does that work? Can you choose when to get out of the breakout rooms?
yeah, it says leave meeting, leave breakout room on the bottom.
Nice. I should keep an eye on who's where, I guess. That would be a good idea. All right, it looks like most people are back. Okay, has everyone clicked in your response? I only see 15 responses.
Oh no, I didn't know it was clicker.
Send it in. And it looks like so far the only difference is sig figs. How many significant figures does this answer have?
2?
2. So how do we do 2 significant figures with logarithmic values?
0.35?
2 numbers past the decimal. So if it was 7.35, then it would still be 2 numbers past the decimal. That's 2 significant figures. I like how Sarah Ray is doing this outside. I'm kind of jealous. I wish I was outside.
Well, yeah, I'm at my mom's house and she has like 6 dogs and they're loud, so.
Sounds miserable. Okay, we have 19 responses. Anyone still waiting to click in? But as far as I can see, everyone's clicked in with 0.35. Okay, so can I have one person just talk through how they did this, make sure we're all on the same page, and then how did you check your answer to make sure that it was logical? Maybe I can ask Sydney. Which Sydney wants to go? All right, Chastain. So I can't see your face.
Okay. Pretty much what I did is I just took the negative log of the 0.45. I didn't check it, and I don't know how to check it, so I can't answer that part.
Okay, it's a good start. Sydney McCann, how did you verify or decide whether this is a reasonable number or not?
I decided that it was reasonable because HNO3 is a strong acid, so it completely dissociates. So I didn't like have to do like an ice table. So I figured just
Okay.
like, taking the log was good enough. That's what we talked about in my break room.
So you said you take the negative log of 0.45, and that assumption that you kind of stated, but I'm going to really emphasize, is what being a strong acid tells you is that you put it in water and you do not have an equilibrium arrow. All of it goes to this side. So whatever your starting concentration of nitric acid was, that is your final concentration of H3O+. So this is something that I will ask you all to memorize, is what the 6 strong acids are, so you can recognize them and not have to look it up. If this was not a strong acid, you would have to go look up what the Ka value was and do an ice table. So what I heard discussed was the first step, is it a strong acid, yes or no? The more you have those memorized, the quicker it's going to be to solve these problems. If it is a strong acid, we can take the negative log of the concentration, assuming that 1 proton is released for every 1 strong acid. Then if it's not a strong acid, we need to find the Ka value. How do we know that the number is reasonable? I think that Sydney was saying that, well, negative log of it should be right. But how do we know that 0.35 is a reasonable number? Can I hear from someone in the group that I broke out into? Tina, I haven't heard too much from you.
Yeah, so we were thinking, well, we answered the question if it's a strong acid or not, and then we decided that it's a strong acid. And we talked about how strong acids have lower pH. So we got 0.35 as our answer, so it's a whole, like, it's really small. So we decided that since strong acids have a lower pH, so our answer was correct.
Great, or so at least it's on the right side of 7. So that's kind of our big reference point. The other thing that we pointed out in that small group was that if you have a 1 molar solution of H3O+, you take the negative log of that, that actually gives you a pH equal to 0. Which sounds crazy, but it turns out the 0 to 14 scale is not our limits. You can have an acidic solution that is stronger than a 1 molar solution of H3O+. If you do, it's going to have a negative pH. You can also have a pH that's higher than 14 if it's really, really basic. So just know that 0 to 14 is a normal range, but we can have a pH outside of those. Okay, I think those are my points here. So I'm going to go ahead and close this out. And go ahead and stop the poll. I guess I should probably be clicking through these. The next question is, what is the pOH of that solution? We're not going to go ahead and break out rooms for this. So go ahead and click in the pOH of this same solution. All right, we've got 11 responses. All right, we're up to 19. Carter, how did you answer this question?
I wasn't 100% sure, but I just put 10 to the negative power of the pH that we found from the first problem. It just gave me the same answer. So
Negative 0.35.
is in 0.45. It
Okay.
gave me concentration.
So similar value to what we had before. Can I ask for maybe let's do Taylor Arnold? How did you approach it?
Well, since we found the pH in the last question, I just did, because isn't pH plus POH supposed to equal 14?
Absolutely.
And so I just did 14 minus the 0.35 and got 13.65.
Great. So one of the hardest things about this part of the semester is we start dealing with logs. And so when is it that we use a log? When do we put something to an exponent? How do all these things fit together? So I think that that was a good example of kind of trying to keep things straight. And the most beneficial way that we're going to do that is by practicing and going through a lot of problems like this. When I mentioned that those POGIL activities were a really good resource, I'm not kidding at all. Some of you might have a lot of challenge to find free time, but if you can find free time now with all this other stuff going on, maybe you have more, maybe you have less free time, try to really work through those POGIL activities. 42 through 46 are the POGIL activities that are really valuable. I know that there were a few people today in workshop and Trip 2 was able to lead through those. I will say though that we had 0 people show up to Josh's Tuesday night session again. And I know Josh is a really good facilitator, so it's not about him. It's about maybe that time just doesn't work for people. So I'm going to go ahead and cancel that Tuesday night workshop time since no one's showing up. If you have a time that you think would work, there's a little chat window in Zoom. You can go ahead and add any suggestions for when we would have the second workshop time in order to have a facilitated time to kind of go through some of the stuff we're working on. That's going to be my best option for now. And we'll see if any of those fit with Tripty or myself, or we can have extra office hours, those kinds of things as well. But we will not be holding the workshop on Tuesday nights anymore. I'm canceling that because it's been a number of nights where Josh hasn't had anyone come, which just means it doesn't work for you all. Okay, so we're on the same page. Let's do another clicker problem here. Put it over here, clicker problem. So now I want to know what the pH is of a solution at 0.45 molar of HNO2. I'm going to send you all into breakout rooms.
Wait, I have a question real quick.
Sure.
On the question we just did, how many sig figs would it be?
Great question. So 13.65, how many sig figs is that for a pH value, POH?
4.
Sarah Ray? What did you show?
2, because however many is after the decimal.
Exactly. So 13.65 is 2 significant figures because it's a logarithmic number. So good question and good answer, Sarah Ray. All right, I'm gonna send you all the breakout rooms now. Hey, Stacy. Are you done with your room? Is that why you're back here?
Yeah, that's why.
Okay, sounds good. I'm gonna jump in. Were most of the people in your room done?
I think they're still working on it, but I took some notes on the primer, so I kind of already knew. That's why I was able to finish it quick. It was similar to one of the questions on the primer.
Sounds good. All right, I'm gonna go jump in the rooms and see how they're doing. We'll probably end pretty soon.
I love how we're the first one again.
Looks like Taylor's team blue over there.
Yeah,
Are you
we
wearing
finished
matching
with-
shirts? All right, looks like almost everyone's back. Can I get a thumbs up, thumbs down how challenging that problem was? Is that tough to get started, or like we kind of got this on lock? Not great, pretty solid. Okay, I see some sideways thumbs, some up thumbs. Let's go ahead and take a look at the values that we've got. Got a mix kind of all over the place. 1.8, 1.75, 0.1, 7.04. Okay, before we do any calculations, what is the first question we ask ourselves?
Is it a strong or weak acid?
Say again, Aislinn?
Is it a strong or weak acid?
Or is it a base? Strong or weak acid, strong or weak base? And we haven't really focused on the base as much yet, but we'll get into that. Okay, and so what did you decide on this one, Aislinn?
A weak acid.
Okay, and the reason we know that is because it's not one of the strong acids and it doesn't have a negative charge. So most of the time that's going to be a weak acid. We can also look up its Ka value. So what's a reasonable pH value for this? What are we going to use as a classification? Greater than or less than a certain value or a certain range? What are we thinking?
Maybe less than 7.
Yep, that's it. That's all I want you guys thinking about. It's an acid. Acids are less pH less than 7. We don't know how far down, because if it's really, really, really concentrated, even if it's a weak acid, it's still going to be really strongly acidic and a very low pH. So let's just say the pH is going to be less than 7. And in this one, because of the problem we just did, I think it's safe to say that it's going to be between pH of 7
Look at me.
and 0.35. It's going to be between those two, because we know a strong acid gives at this concentration, right? 0.45 was the same concentration as nitric acid. That gave us a pH of 0.35. This is not strong, so it's going to be a little bit less acidic than that somewhere. Okay, so that's our ballpark. So then I'm going to ask for Gabby to talk us through kind of the steps that she did in order to answer this question. Gabby, do you mind?
So starting just at the very beginning with the ice table, or?
Yep.
So
I'm gonna share my screen so I can draw on it. Should show up. All right. Go ahead, Gabby.
So I draw the ice table for the for the values and for the equation.
One person without muting their maybe that's Sarah, right?
Oh, I'm sorry.
HNO2 plus water. Okay, Gabby, I've got my ice table here.
Okay, so the HNO2, it starts with the value of 0.45 m, the molarity.
Yep.
Yeah, the molarity. And the other two start with nothing. Then for the change, you have minus X under the HNO2, and the other two have plus X.
And once again, we go back to the reason that we can tell it's minus X on the left and plus on the right is because Q is not equal to K. In order for Q to equal K, we have to use up reactants and form products. And then Gabby, last line.
Then just 0.45 minus X, and then the other two are just X.
Okay, then what next?
Then I went and found my K value, which was 4.5 times 10 to the negative 4.
Okay, and if you're doing this on homeworks, then I want you to look up the value of Ka. For the exam, probably what I'll do is I'll send you a PDF with a whole bunch of Ka and Kb values, and you'll use that as a reference. Okay, that equals?
I did X squared over 0.45 minus X.
Okay.
And then I just solved that equation to get well, since the 4.5 times 10 to the negative 4, I think it's doubled. It's still less than 1, so the equation can be simplified.
Okay, so there's a couple of tricks that you might know of how to do this, but for now, I'm going to say we always assume that the original concentration is going to change by such a small amount that we're always going to make the assumption that that minus x really doesn't affect the value much.
Okay.
So we're always going to make the assumption, and then we're always going to check it. So that's, I should probably actually do, is about equal to x squared over 0.45 molar. Okay, and then if we solve for x, what did you get?
I got 1.34 times 10 to the negative second. Oh, 1.42. Sorry.
0.42.
Mm-hmm.
Okay, pause. What is that x value? I want someone else to answer this. Maybe Samantha. What is the x value we just solved for, and how does that help us answer this question? Samantha, you cool me calling on you?
Yeah, I had it. Zoom does not like my computer. The X value, isn't that the? I know what it is, but I don't know how to say it.
Okay.
The X value is the same as the concentration of the H3O.
It looks like we're
Which
losing
we
a little
need to
bit.
know to find. Oh no, the NO2. Can you hear me?
Yeah, sorry, it's cutting out a little bit there, Tracy.
Sorry, my internet's slow right now.
It's amazing
So
how
we need
that.
Yeah, that would.
the X is equal to the concentration
Of
the NO2 and the H3O plus
at equilibrium.
at equilibrium, sorry.
Great. So it's equal to the concentration of each of those because they're equal to each other. It's also equal to the amount that the 0.45 molar decreased. It's also the change in initial concentration. It's also how much increased in the concentration of NO2 minus and how much H3O plus increased. All those are what X means. The one that we really care about is the one in the box and the square. That is the one that's most important. So Gabby, what did you do as a final step with that X value?
I believe pH is equal to negative log of that number. So that's what I did.
Perfect. Which equals, what did you get for numeric value?
I got 1.85.
All right, let's see. Actually, I don't know if I can, let me check out the clickers. I think I got to undo the drawing screen. 1.8, 1.87, 1.85, 1.75. How many sig figs should we have in our answer? 2, I see Carter doing. So is that 1.8 or is that 1.87, 85? Which one of those is right?
8.5.
I agree. And I didn't do the calculation myself, so this might be close enough. I'm not sure. I'm not going to say which one of them was right. Or one of these three values. It's somewhere in that ballpark that's a reasonable number because it's between 0.35 pH and 7. And it has 2 numbers past the decimal. And remember, the 2 numbers past the decimal means there's 2 significant digits. All right.
I have a question on Monday's class. The the paper with the stuff that I just blanked on what this is called. The sheet you gave us for Monday. In the chart, it says nitrous acid's Ka is 7.1 times 10 to the negative 4.
Interesting. So if you use that value, you would get a slightly different answer. So did you get 1.75?
Yeah, I got 1.75.
Okay. So I will give you a set of numbers that you can use on the exam that are set. The difference is with some of these values, they're done at slightly different temperatures. And so that impacts how much the H plus ions are released.
Yeah,
So
the chart from Monday says it is the Ka at 25 degrees Celsius.
yeah, so they should all be the same, but there's slight differences. So you're going to find slightly different values as you look around. So hopefully OWL is forgiving in that kind of a small deviation, but that number should make sense. If you think about 4.5, 7.1 times 10 to the negative 7th, what we really care about is that exponent, 10 to the negative fourth, right? 10 to the negative fourth exponent tells you it's a weak acid. 10 to the negative 10th would be such a weak acid it's not even considered an acid.
Yeah.
10 to the
Okay, I thought I'd ask.
yeah. So those are kind of the important things to keep in mind. So that's
OWL
why
has all of the KAs listed in the references.
the OWL does.
Yes, sir.
Great. So use those when you're doing your calculations for your homework. Thanks for pointing that out.
Sorry.
All right. So go ahead.
I'm sorry. You said OWL gives us.
Yeah, they're in the references.
Oh.
You know, like when you're working a problem, there's a little link at the very top. It says
Right.
references. Click on that. It's in there.
Okay, that's helpful. Thank you.
Great. And that's a really important link to always have out is those references. So keep that in mind. A lot of times it'll give you other values that are really important for problems. So I think we can do this problem relatively quickly. What is the pOH of that solution that we just talked about? Carter, you're going to answer this one when we get through it. So I'll give you about 1 minute to answer this question for everyone. All right, we got 20 responses. Carter, you want to talk us through how you solved this problem?
Yeah, well, for my pH, the first time I got 1.75 instead of 1.85. I think I just used different Ka values.
Yep.
But I did 14 minus 1.75, and I got 12.25.
Fantastic. All right, and so this is based off of, like you said, the Ka value that you used. We should all be using the same one in the future. So maybe I'll figure out, I'll give you guys a table that we can use for everyone that we do in class, because it's going to be a little annoying, I imagine, to have values that are slightly different. Is there anything we forgot to do in that last problem?
Check to make sure that the that we were justified in making the assumption.
Fantastic. So how do we do that, Gabby?
I honestly have forgotten how.
All right, who wants to volunteer to talk us through that?
Do you do 0.014 divided by 0.45 times 100 to see if it is less than 5%?
So where'd you get 0.14?
That was the X that I calculated.
Okay, so remember what we're trying to say is we said 0.45 minus X is about the same thing as 0.45. So what we're trying to do is we're trying to prove whether that X value is less than 5% of the 0.45 that we did. So exactly what Taylor did here is right. So we say, what is that X value? How does it compare to the initial concentration? Multiply it by 100 to get a percentage. And what did you get for that percentage? And we would want to use more than 0.14 if we could, whatever the value was that we came out with for X.
I got 3.1%.
Okay, and so that might be slightly different depending on if we kept all the numbers from the calculation. So as soon as you calculate that X value, the first thing that we should do is check to make sure that's less than 5%. That way it's in our calculator, we can store it so we can use it later. But that's a good way to do. So is the assumption valid? Are we okay with this? Okay, we're good. So now the big question is, I'll go ahead and close this out. The next question that we have on the worksheet, and based on what you had for your answer, it's 2 past the decimal. What is the pOH of a solution that's 3.25 times 10 to the negative second molar of our nitrous acid, HNO2? I don't want you to solve this. I want you to think about the process. So go ahead and spend the next 1 minute thinking about the process, how you're going to go through this. And then I want to hear from, let me scroll through. Is this scaring people by calling on individuals? Are we doing all right? Amber, do you mind if I ask you to describe the process you would use to answer this question in a minute? Thumbs up, thumbs down. Okay. So I want everyone on their own to think how we would do this. All right, minute is up for setting up the problem. Remember, we're not solving the numeric value. I want to know the process. So Amber, can you talk through it without necessarily all the specifics of the numbers that you calculate? You would calculate all those things.
So I kind of used the last problem and just compared. So the last problem we had 0.45 molar. This one would be about 0.0325. So we have less to even start out with. And because it's a weak acid, it's going to dissociate only that little bit. So now it's going to be dissociating even less because we have less. So you would think the pH of the total solution would end up being higher at that point because you have less acid to it. So the pOH would actually be less.
So it's going to be, and maybe the way to say it is going to be closer to 7. That's what
that's a lot easier.
It'll be more neutral because it's a lower concentration. So I think using the last problem as a template is a really good idea. So we would need Ka. We need to do an ice table, fill it out. It would look exactly the same. The only difference is what is our initial concentration. We make the assumption. We check the assumption. Did anyone get that far? To make the assumption and check the assumption and figure out what X is and if that's less than 5%.
Yeah.
What'd you find? Is it less than 5%?
It's more.
What percent did you get?
11.7%.
That means that initial weak acid disassociates more than 5%, so we can't make the assumption. So how would we have to solve this problem?
With the quadratic equation.
Okay, point made. We're not going to do it. But what you'll notice is the lower the initial concentration is, gives a larger ionization. So it's an inverse relationship. Lower concentration, higher ionization. So when we have concentrations that are above, I don't know, 0.1, 0.2, 0.3 molar, a lot of times the assumption is more valid than something that's a really small initial concentration like this.
Can I ask a question? I'm sorry, my neighbor just came and knocked on my door, and so where did the 11.7% ionization come from?
So Jesse went through the calculations to find out using an ice table with this initial concentration, what your X value is. If we made the assumption that X is less than 5%, and then he compared whatever the X value was that he found to
Okay.
the initial, and it was greater than 5%. So the assumption is not valid.
Okay, sorry.
No worries. All right, so that was the whole point of that question. I'm not actually gonna have you click in the answer. So go ahead and stop working on that problem. We're gonna switch gears a little bit. And now we're gonna start talking about bases. So we've talked before about conjugate bases of weak acids. So for example, that last one, NO2 minus, was a weak base. But so our weak bases are either gonna look like NO2 minus. They're gonna look like the conjugate of a weak acid. We also showed CO3 2 minus. We also showed HPO4 minus or HSO4 minus. So a lot of times if you see that negative sign, then that kind of tips you off that it might be a base. The only time that is not true is if it is from a strong acid. This has no basic strength. If it comes from a strong acid, that means, remember, that these two are so weakly attracted to each other that they stay completely separate and surrounded by water instead. What that means is that this is a crap base. It does not act as a base at all, so we're not going to call that a base. Same thing is true for this one I wrote up in the top right corner, because one of our strong acids is sulfuric acid. When sulfuric acid loses one proton, it becomes HSO4. That tells us that HSO4 minus is a really terrible base because it doesn't even have enough attraction to an H plus to act as a base. So we're not going to say it acts as a base. So any conjugate of a strong acid doesn't even count. So with that in mind, the other category of weak bases, besides the conjugate of a weak acid, is anything that has a nitrogen with a lone pair on it for the most part. So ammonia is a really good example, NH3. NH4 plus is that same molecule that is taken on an H plus, and it actually uses that lone pair of electrons to bond to an H plus ion. And that's why it has a positive charge, an extra proton, and no lone pair. Conversely, anytime we see a nitrogen with no lone pairs and an H, it acts as an acid, a weak acid. I don't know what I just wrote there, but hopefully you get the point. It acts as an acid. So nitrogen with a lone pairs that has a hydrogen on it is going to act as an acid and donate that so it can have its lone pair back. Okay, so what you're looking out for is a nitrogen with a lone pair or the conjugate of a weak acid. That tells you that we have a weak base. And so we discussed yesterday that a weak base, we can say, how does that interact with water to pull off a proton? How likely is that to happen? And we're going to call that Kb. And when it does pull a proton off from water, it forms a conjugate acid and OH minus. So just like Ka, Kb is written out the same way. And it tells us the larger that number is, the more likely it is to push that reaction to the right, meaning it acts more like a base. The more the top, the numerator, the more it's able to go in this direction, the bigger these two numbers are going to be. The bigger the top number is going to be, which means that it's a bigger value of Kb. So the bigger the Kb, the increase, the bigger the basic strength is of that weak base. So out of these options here, I want you to choose which one of the ones in your table that's on your worksheet as well. Which one of these is the weakest base in that table? And I said Ka, but then I gave you a multiple choice. Is this a pretty bad question? This is a pretty terrible question, huh? Why is this a terrible question? Can anyone tell me how this is terrible?
Because I don't understand it.
It's actually not a completely terrible question. But let's say, are we at the top of the table or are we at the bottom of the table for the weakest base in that table?
I think the top,
Why?
it says negligible.
Great. Context clues. And then what about, so I would argue that negligible means it doesn't even count as a base. So that's why this is not the best question. So that one would not be the right answer because it doesn't even act as a base. We can't even say NO3 minus acts as a base. But F minus is probably our weakest base in this table. So how would we answer this question? Go ahead and take a minute and answer, click in what the Ka would be of F minus, which is the weakest base that actually acts as a base in this table. Do about 45 more seconds.
Wait, what are we solving for?
We're solving for what the Ka value is for the weakest base in the table, which is our F minus, because NO3 minus is not even, doesn't act as a base. So our weakest base is F minus. Got 9 responses, so need a little bit more time, it looks like. About 30 more seconds. All right, Stacy, can you share how you answer this problem?
What do you mean? Like how I chose the weakest one?
No, once we had F minus is the weakest one. Well, I guess both. How can you describe that that is the weakest base? And then how do you find the Ka of that?
It's the weakest base because it has the smallest KB value.
Great.
And then you would find Ka by subtracting the KB value from 1.0 times 10 to the negative 14th, I think.
Except it's not a subtraction. So Ka times Kb equals Kw. So how would we find Ka if we knew Kb? Did we lose Stacy? Stacy still there? We lost her. Danielle, how would we find Ka if we have Kb?
You would divide KW by KB.
Fantastic. And so that Ka value is for the conjugate acid, HF. That says how strong of an acid is the conjugate of F minus. All right, and I believe, so it's really important that I was asking here for Ka, not Kb. And so that kind of looks like the majority mix up there. So if we have a weak base, well, if we have a compound, how do we know that this is a weak base? Dimethylamine, CH3, 2NH. How do we know that that's a weak base, first of all? Or is it a weak acid? Michael, what do you see when you look at that compound? Michael, you with us? All right, let's ask for Samantha.
Okay, it's a weak base because whenever you have nitrogen bonded with something with a lone pair present, that makes it a weak base.
Yes. So in order to have a lone pair, it has to have 3 things, not 4 bonded to it. So that's a really important component. All right. So I think what we'll have to do is we're going to have to leave this one. But let's think about the approach. We have a weak base. We are talking about putting in water. We know what the initial concentration is of our weak base. We know our KB value. So does anyone want to just take a stab at explaining what the steps might be to finding the pH of the solution?
You might have to find the Ka and then solve it the way we did the other ones.
So we could, but then we don't know the initial concentration of our weak acid, the conjugate acid. So I might suggest instead that we use Kb. We describe how likely is this to take a proton from water, and it forms the conjugate acid in OH minus. And then we know what this value is. So now the difference is we can do an ice table, but the big question is, what is the X value that we end up solving for in this case? We go through an ice table, and we go through and we do all of this. What is the X value that we're solving for? Can we just take the negative log of that X value to find the pH like we've done in the past? Why not, Verda?
We have to find the pOH value.
Great. So the X value is the concentration of OH minus at equilibrium. From that, we can find pOH, which then allows us to find pH, as Carter is really good at now. Okay, so I'm going to leave it there, but I want you thinking about how we would go. So work through this problem yourself. Make sure you find a pH that's reasonable. I'm going to stick around for a little bit after our class ends if you want to talk through any of this. I know that you have lab. Potentially, if you haven't finished yet and turned everything in, then Humendra is there available for you. But feel free to stick around, ask me any questions, or if you want to do extra set of office hours, I'm available Thursday, Friday, and then I have my regular office hours on Monday. So I hope you all have a good evening, and feel free to stick around if you would like. I'm going to go ahead and stop sharing and end the recording.